Myself P. Suresh. I am assistant professor in civil department in Mlritm, Marri Laxman Institute of Technology and Management. Subject name we are discussing advanced structural mechanics. Example strength of materials and engineering mechanics. Today topics symmetrical and non-symmetrical bendings. So these are the course objectives. Course objective means there are only four course objectives. First one, to learn how to calculate static and kinematics, determine the of various types of structures. So structural mechanics, there are so many types of structures and different types of beams. So we find the already discussing in engineering mechanics and strength of materials, advanced structural analysis. Next, coming to the point, second point, to formulate the stiffness matrix for continuous beams. Continuous beams more than two supports, it is called continuous beams. Portal frames and trusses. Trusses, so many trusses, twin trusses and king trusses. To formulate the flexibility matrix for continuous beams more than two supports, it is called continuous beams. Next, coming to the point, fourth point, to obtain the global stiffness matrix by assembling the element stiffness matrix. These are the course subjects. Course outcomes. After finishing the syllabus subject, we learned after completion of the course, students should be able to these four types course outcomes. Formulate the stiffness and flexibility matrices. Stiffness means structure stability and structure strength, structure deformations for various types of structures. Next, course outcome second, analyze the continuous beams, portal frames and trusses by stiffness methods. Structures approximate. Second one, same as it is. Second one is stiffness matrix, third one is flexibility methods. There are the two types, stiffness method and flexibility method. Fourth, coming to the point, fourth point, solve these trusses, continuous beams, portal frame using element approach of stiffness method. These are the syllabus. Advanced structural mechanics. First unit, we are discussing only first unit, unsymmetrical bending. Unsymmetrical bending, subject unit 1, definition of shear center in bending, symmetrical and non-symmetrical bendings. Today topic is symmetrical and non-symmetrical bending. Bending stress in beams subjected to non-symmetrical bending. Deflection of straight beams subjected to non-symmetrical bending. This is the first unit, unsymmetrical bending. We are discussing today topic unsymmetrical bending. What is bending? What is bending? Bending beams. Bending of beam or structural elements refers to the deformation or curvature of a beam or structural element when it is subjected to an external load. This load causes the beam to bend and the bending behavior depends on the magnitude, directions and location of the end. For example, one take the beam directions, anti-clockwise directions. This is called magnitude directions, moment A, moment B. And location of the load. Some loads, point loads, there are three types loads. Point loads are concentrated load, UDL load, uniformly distributed load, and UVL, uniformly weighing loads. These are the three loads. First one, point load. Second one, uniformly distributed load. Third one, uniformly weighing load. These are the loads. So example one, take one beam. Beam is direction, magnitude, directions and location of the load. When a beam is bent, for example, when a beam is a horizontal structure. When beam is a bent, it is experience internal forces and moments that vary across its length. The bending includes. Next, there are the two types, compressions and tensions. Compressions on one side of the beam, the side opposite to the direction of bending. Means one side you can compress the beam, the side opposite to the direction of bending. Tension on the other side, the side towards which the beam bends. Shear stresses across the beam's cross sections. Symmetrical bending and definitions. Define a symmetrical or bending. Symmetrical bending, when the bending moment acts in plane that coincides with or is parallel to a plane containing the principal centroidal axis of inertia of the cross section. For example, symmetrical beams, I section, L section and T section. I section, L section and T section, we refer to the central line, x axis, y axis. At coincident point, it is called centroid. G or O, origin, centroid. The neutral axis is perpendicular to plane. This is neutral axis. Neutral axis, NA. The neutral axis is perpendicular to the plane of bending. Stress distribution is similar, linear variation about the neutral axis. Symmetrical bending, key characteristics of formulas. Symmetrical bending formula, sigma equal to my by I. M equal to bending moment. M equal to bending moment and y equal to distance by 2 and I equal to moment of inertia. Moment of inertia are rectangular section or circular section. For example, we can take rectangular section, BD cube by 12, where M is the bending moment about the principal axis, y is the distance from the neutral axis, I is the moment of inertia. Conditions, assumptions, cross section of symmetric, load is applied in plane of symmetrical. Example of cross section, rectangular section or I beam section, L section, beam symmetrically about x axis. Symmetrical diagram. This is the symmetrical diagram. This is the y axis and x axis. This is called as central line. G neutral axis, NA neutral axis. The moment M equal to moment. The moment M is found to coincident with the axis of the couple as well as the neutral axis. Thus, it is symmetrical bending as it bends that planes. See example figures. I section. So this is the width of the flange, top flange, width of the bottom flange. This is width of the top flange. This is called web. This is called bottom flange. See the I section. I section at a x distance, x equal to 0. X equal to 0. So symmetrical centroid is 0 at a center point. This is called 0 centroid. Non-symmetrical or unsymmetrical bending. Define unsymmetrical or non-symmetrical bending occurs when the plane of loading or bending does not coincide with a plane containing the principal centroidal axis of the cross section. Coincide. So does not coincide. For example, angular sections. See this one unsymmetrical bending. Coincident sections x-axis and y-axis are not coincide. So it is called unsymmetrical bending. Symmetrical bending is coincide. Symmetrical bending is coincide. I-axis lo y-axis and x-axis. Y-axis is coincident. It is called centroid. G or O, centroid. This is called, this figure, unsymmetrical. X-axis and y-axis not coincident, does not coincide. It's called unsymmetrical bending. C, does not coincide with the plane containing principle of centroidal axis of the cross section or the section is unsymmetrical and load acts about a non-principal axis. Non-principal axis. In this case, the neutral axis does not remain perpendicular to the load plane. Axis does not to remain perpendicular to the load plane and stresses. Distribution is more example. Distribution is more example. This one. Next, causes of symmetrical bending. Section is unsymmetrical. Example: angle section, channel section, L sections, different sections, angular sections. So, and load may act through centroid, but section lacks symmetry. Through centroid, but section lacks symmetry. Section may be symmetrical, but the load line is inclined or not in the plane of symmetry. So bending moment acts about a non-principal axis. Load line does not pass through. Load line does not pass through the shear center. Shear center. Combined bending torsion may occurs. What is the shear? Shear is out of the beam edges. Out of the beam edges. Shear. Next, difference between symmetrical and unsymmetrical bendings. Symmetrical bending coincides with parallel to principal axis. Unsymmetrical means does not coincide or sections unsymmetrical. Neutral axis location perpendicular to plane of bending often through the centroid. So this is called perpendicular. At centroid, perpendicular line at centroid, it is called coincide. Is symmetrical. Does not coincide, it is called unsymmetrical. Neutral axis may shift not perpendicular, may not pass through centroid. Simple symmetric about neutral axis. Complex non-symmetric. Examples: rectangular section with loads and symmetrical plane. Rectangular section, one you can take one rectangular section. Y axis, y dash, x dash. This is called centroid, O or G, centroid. Rectangular section with load in symmetric plane. Angle section means L section. This is called angle section. Angle or channel section or loaded inclined plane. Shear force at a section at a distance x from, for example, you can take one simply supported beam. This is called load A, B, some distance is called x. This is called L, length. X from P and consider the force at the left, then Vx equal to negative P. P or W. For all values of x negative in sign, that is the shear force. Negative in sign, that is the shear force to the left of the x section or in downward direction, and therefore negative. So it is here, see the figure, upward direction and positive, downward, negative. Bending moment. Taking moment about the section gives obviously to the left of the section. Bending moment mx equal to negative px. Negative sign means that the moment on the left hand side of the portion is in the anti-clockwise direction and is therefore taken as negative according to the sign conversation. So that the maximum bending moment occurs at the fixed end, that is m maximum equal to negative pl at x equal to l, at x equal to l. So this is called length l, length. L. So x distance equal to L. See the different types of loading and the shear force bending moment diagrams. Observe it. This is point load, shear force and bending moment diagrams. Different types of loading and the shear force and bending moment diagram. Cantilever beam with a concentrated load point at its free end. You can take cantilever beam, one side fixed, another side free. One side fixed, another side free. It is called cantilever beam. So load is applied to P. Some load free end P. Some distance. This distance L. This is called X. So see the figure. And cantilever beam shear force diagram is rectangular shape and bending moment diagram shape is triangular shape. See one other figure. Different types of loading and a cantilever beam with uniformly distributed load. This one is point load, this one is uniformly distributed load. So uniformly distributed load cantilever beams, one side fixed, another side free. Uniformly distributed load, you can take beam any point, load is applied, W kilonewton per meter, kilonewton per meter. Length, distance at point load, some distance L and centroid, this is X. See the figure. Shear force diagram is shape is triangular shape and bending moment diagram is parabola shape. So shear force equal to W, shear force Fx equal to negative sign W load into length, and bending moment at cantilever with the UDL negative WL square by 2, WL square by 2. When a beam is bends, the top fibers of the beam are usually in compression, the bottom fibers are usually in tension. There exists a layer in between the neutral axis where fibers experience no longitudinal stresses. Bending is governed by the bending moment M equal to M by I, F by Y, E by R, where M equal to bending moment, I equal to moment of inertia of cross section, F equal to stress, E equal to Young's modulus of velocity, R equal to radius of curvature. Types of beams. Beams may be classified as there are 5 types. First one, simply supported beam. Simply supported beam. Draw the simply supported beam. Point load, RA, reaction RA and RB, supports, into supports A and B. This is called simply supported beam. Cantilever beam. Cantilever beam. One side fixed, another side free. At point load free end, length, distance equidistant A. Next, overhanging beam. This is called overhanging beam. Next, fixed beam. Fixed beam, both side fix. Fixed beam and continuous beam, more than two supports. More than two support is called continuous beams. It is called these types of beams. Next, types of loads: concentrated load and uniformly distributed load and uniformly weighing load. This is the types of loads. Point load means at midpoint or center point. Uniformly distributed load, distributed to triangular section, and uniformly distributed load, different types of loads, and uniformly weighing load. This is the figures of bending moment deflections, bending moment diagrams, deflection of the beam, and simply supported subjected to a moment. What is unsymmetrical bending? Unsymmetrical bending in definition, already we are discussing. This is called neutral axis at center, neutral axis, and y axis and x axis, cross section and shear center location. NA means neutral axis. These are the reference. Thank you.